Hi everyone, my name is Vadym Demchuk and I'd like to present a publication onto the topic Holistic Adaptive Optimization Techniques for Distributed Data Streaming Systems. The authors are Vysotska, Iryna, Kyrychenko, Vadym Demchuk and Iryna Gruzdo. The purpose of the study is to analyze the existing approaches for performance tuning of real-time data services, identify strengths and weaknesses, then to provide a comprehensive approach that overcomes the existing challenges, conduct an experiment, and evaluate the results. Let's dive deeper into the big data world. Streaming has become a crucial part of different data pipelines and for different industries. Such as IoT monitoring, such as business industries, starting from personalization, ending with fraud detection for different science tasks. This is because of the situation it gives our outcomes, such as improved customer experience, proactive problem solving, and such solutions, streaming solutions are very competitive on the market in comparison to the batch approach. So streaming part is increasing across different data pipelines. This is obvious because the business needs to handle data on the fly in real time, and from this instant data, the business needs to get some knowledge. Let's consider challenges of real-time data services. The first challenge is that once the application is deployed to production, it handles more and more data. So the throughput is increasing, it's constantly increasing, and data records is becoming bigger and bigger, while things are becoming overloaded. It stores more and more data with some complex dependencies. So obviously, performance needs to be tuned. However, this is the second challenge. Such data streaming pipelines are built using different technology stack, because the technology stack is consists of various different frameworks, different cloud solutions. So it's pretty hard to apply the same best practices for every framework, source, and things. So let's consider existing performance tuning approaches. So the such techniques are well covered in the mentioned research papers. The most popular are cost modeling, simulation-based experience-driven, but they are very obvious. The most interesting are ML approach and automated or adaptive approach. So the ML approach, it leverages parameters based on metrics consumed during the application historical runs, while the automated approach are built on top of ML, but it changes configuration on the fly in real time. So, and these two approaches, it considers configurations and parameters of the processing engine. It doesn't take into account the property of the sources, the property of the strings, the current metrics, the current configurations. And of course, it doesn't change the parameters. But what is performance tuning? So, if we consider a data pipeline, it consists of a job of some properties of the input stream, of the target sinks, of the compute cluster itself, and of course the configuration set of the source, of the job, of the sinks. So the performance tuning statement is to find an optimal parameters, configurations, when we try to consider existing metrics. As mentioned earlier, the disadvantages of the mentioned techniques, they don't take into account properties of the sources of the sinks, and their configurations. So our holistic adaptive optimization approach consider these configurations and properties. So we collect data in real time using data collection service. It connects to different sources, process engine and things using the connectors. So if you need to add another service, you implement another connector. Then this connector, this data collection service, supplies metrics and configurations to a ML module so that it can leverage the configuration set. And then the console module applies these results, changes on the fly into sources, process engine, and things. And to evaluate benefits of this approach, we've conducted some experiments. To evaluate the provided approach, we chose the following technological stack. So we used Confluent Kafka. This is a standard source for data streaming. Also, we chose Databricks Apache Spark. This is a good implementation of Apache Spark. It has more properties for parametric tuning, and itself the engine has better performance than the open source. And as a sink, we use Delta Lake format. So this is like approach when you store files in Delta format, Delta tables called in some blob storage. For this case, we chose Azure blob storage. So let's move on to the data. For the experiment, we took a huge dataset of 80 million records. The total size of this dataset was 18 gigabytes, so this is a huge one. And the dataset was in our format, so the data was even compressed. And the cluster we used in Databricks was this total number of CPUs and more than 180 gigabytes of total memory. So we tested our approach on the real production application. And we've conducted a couple experiments. In the first experiment called BASE, we used the existing ML tuning approach, adaptive approach, while in the second one we've used our HAOT approach. So let's check the results. So the ML model cases chosen some different parameters. However, only one parameter was the same, this spark memory fraction. Well, this is obvious because this parameter depends only the cluster memory and CPU utilization. Well, since it doesn't depend on the source and sink, in the both cases, ML decided to use the same options. Okay, while, for instance, if we check this parameter, this is a very important parameter. Here, the application decided to, ML model decided to reduce, and this is a best practice to use less shuffle partitions for streaming. The best practice is to use the number of partitions in source Kafka topic. Well, and the default one is 2000, so this is a good choice. While the HAT decided to decrease to 24, and why? Because it used mean partitions. This is Spark is able to read some Kafka partitions in parallel by 3 consumers. So in total, it boosts the performance in 3 times. This is a good one. This is a good use case, and the model found the dependency that these mean partitions should correlate with shuffle partitions. Okay, and we can see that our team decided to increase max offset per trigger. So it has done that respectively to this number of partitions. So here the partitions Spark partitions parallel task count is 6, while here is 24. As a result, we can see that for almost all the metrics, HE has better results. For instance, the most important here, processing rate, it increased by 40%. It means that application can process more data, can handle huge data throughput without scaling well. And we can see that since input rows increased, the total execution time decreased for HAT use case. But this is not a problem. This is just about small latency. The most important that the application can now handle a huge data workload. In conclusion, the holistic adaptive optimization technique has the following benefits. The first is that HAOT approach is able to adjust configurations of the whole data pipeline. So it means that the pipeline reacts on the changes in data stream in the targets instantaneously. It also ensures that optimization applied across the whole data pipeline, the sources and the sinks. And the most important part, that a business doesn't need to spend time and save costs, of course, on experienced data engineers, because such tasks of optimization tuning is a complex task and requires lots of time, lots of attention. So that's it. Thank you for your attention.